Hello. Well, in my previous videos, like 2 or 3 videos, I've been talking about concrete and the compressive strength of concrete. So today I want to discuss the compressive strength of concrete, the actual process of testing it, and in this video I will show you the laboratory process of testing compressive strength of concrete and the reasons why we do them that way, and I hope you learn. Hi people, my name is Winnie Okado. I'm a graduate engineer by profession. Welcome to my YouTube channel. If this is your first time here, you're welcome. I do series on construction works, construction materials, the processes of construction. We do series in masonry work, carpentry, steel fixing. We'll be touching on almost all the aspects in construction. Feel free, feel welcomed. Don't forget to subscribe, share, comment, like, and click on the notification bell to get notified on new videos that I will be uploading. And enjoy the video, enjoy the rest of the video. Thank you. So like I said earlier in my previous video, I told you that concrete is a material that is mostly used in construction, and that in itself concrete is very good in compressive strength. That simply means concrete can carry a lot of load without breaking, without cracking. So when we speak of the compressive strength of a material, it simply means the strength of that material to carry a given load without breaking or cracking. So from that you can conclude that concrete has a high compressive strength. That means concrete can carry a lot of load without it being broken. So we said that structures are not only exposed to compressive loads, some are exposed to tensile loads. That is why we reinforce concrete with steel to take care of the tensile stresses in structures that are there. And so today I want us to talk about compressive strength, and like I said, compressive strength is very key, and the compressive strength of concrete depends on a number of things. One of them is the water cement ratio. We discussed about concrete and we said that concrete is a mixture of cement, sand, ballast, if I may use that is mostly used in Kenya, and water. So a mixture of all these is what forms concrete. So the strength of concrete largely depends on the ratio of the water cement ratio, because it is the cement that binds all these aggregates to form a hard material that we call concrete. So if we have too much water, we are redefining the strength of concrete. That means that the strength is reducing. We are going to reduce the strength of the concrete. The compressive strength of concrete also depends on the cement strength. We have various strengths of concrete. We have cement. We have cement that has a strength of 32.5. There is one for 42.5. Depending on the nature of the project you're undertaking and the design, the strength of cement also determines the strength of concrete. Another factor that affects the strength of concrete is the quality control during production. The production of concrete is complex. is a complex system where we have to mix cement, sand, ballast in some ratios. There are ratios that are defined, and not following these ratios just means that we are messing up the strength of the concrete, because a given concrete class is defined by a set of ratios of cement, sand, and the coarse aggregate. So when we are producing concrete, a lot of quality control has to be looked for so that we don't mess the strength of the concrete. And we discussed about the cubes, the concrete cubes. Those are the specimen that we use in this case. So if you didn't see that video, kindly go back to my second video. You will learn about the process of making the concrete cubes, and those cubes are what we use to test the strength of concrete. You will take the cubes to the lab where we will crush them to determine the compressive strength of concrete. So when you reach the lab, what is the first thing that you do? Once you're in the lab, the first thing you will do is book your specimen. In this case, your specimen are the concrete cubes. So how do we book them? When you get to the lab, you will find the lab technicians there. They will take you step by step on what to write about the cubes. So the first step is you will give your cubes an identification mark. That can be done for you by the lab technicians. What will you book then? One, the date of test. What does that mean? An example is, if you made your cubes for 7 days, the 7th day, the day you're going to crush your cubes, is the day of test. So you will write that date. So when you're booking your specimen, the first thing you write is the date of test. Like I said, if it's a 7-day test, you will write the date you're supposed to be crushing the cube. The next thing is you have to write the age of the specimen. Are you testing it for 7 days or for 28 days or for 14 days? You will have to write that. You will write the class of concrete you're using for that. If you cast the cube using concrete class 25, that is what you will write about the class of concrete that you used in your specimen. So once you've booked your specimen, the next step is weighing your cubes. So there is a video I'm showing you of process of weighing. We will put the cube in a weighing machine, weighing balance, to weigh that cube. Why do we weigh the cube? One, to determine the density. Are we using the right density for concrete? Are we using the right quantity? The right concrete, sorry. For example, we know that density of concrete is 2500 kilogram per meters cube. So we will weigh the concrete and write that down. We will find the volume of the cube. What happens next? After you void your cube, the next step is taking the cube for crushing. We use a compressive strength testing machine for that. So once you've weighed your cube, you have its weight, you take the cube into the compressive strength testing machine like shown. So this machine will apply a given load, will apply a load gradually to the cube until the cube crashes. The load at which the cube crashes is what is written down. So like you see in this video, so you weigh your cube, you put it in the compressive strength machine. A load is applied gradually to the cube until it's breaking. So the load that brings the cube to the breaking point is written down. So from there, how now do you calculate the compressive strength of the cube? So the compressive strength of the cube is given by the load at which the cube breaks divided by the surface area of the cube. What am I saying? If, for example, the load that brings the cube to crash is 450 kilonewtons, you write that down. And then, what is the area of the cube? The area in contact with the load. We said we used a cube of 150 by 150 mm. So you find the area of that. That is just 150 by 150. Then the compressive strength is given by the load, for example, for 50 kilonewtons divided by 150 by 150. Then you have to change that 150 by 150 into meters squared, because the load is measured in kilonewton per meter squared. So once you divide that, you will find your compressive strength of concrete. And from there, in my previous video, I showed you that at 7 days, for example, the compressive strength of concrete should have been 65%, should be 65% of the anticipated strength. So from here, you can calculate whether your concrete is doing well or whatever you're doing on site is not correct. So once you have the results, you can compare with the expected results at 7 days to identify what is going on. Are you doing the right thing or you're not? And if not, you should not do that. But if not, you should continue curing properly so that at 14 days a change is seen. And make sure there is proper quality control during production of concrete. Make sure you're using the right aggregates, because aggregates form the bulk of concrete. And also make sure that you're using just enough water, not too much, not too little. Make sure curing is well done on site. And that's all for today. I hope this video helps you learn more about concrete, and don't forget to subscribe again. Welcome back. Until next time.